Question 1. The table below shows the cost to post letters and parcels. So we've got the cost of posting, we've got first class and second class, small letter, large letter, parcel, and their appropriate costs. Use costs from the table to answer the following. So for part A, Maria posts 1 second class small letter and 1 first class parcel. What is the total cost of posting these 2 items? So we want the price of a small second class letter. So small letter second class, that's 68 pence. And then a first class parcel, so first class parcel, that's £4.45. Now this is a calculator paper. I'm going to use my calculator, but these are in different units at the minute, okay? I've got pence and pounds. So what I'm actually doing is £0.68 plus £4.45. It's important to make sure that we get them in the same unit before we start calculating with them. So that's a total of £5.13. How much less does it cost to post 3 large letters second class than to post 3 large letters first class? So we're going to find the total cost for 3 large letters second class. So second class, large letters, so £1.05. So we're going to do 3 times £1.05. Oh. So that's £3.15. And then we need to compare it to the cost of 3 large letters at first class. So large letter, first class is £1.45. So we're going to do 3 lots of that. We want to know how much less it costs, so we're going to find the difference. So £4.35, subtract £3.15. I've already got £4.35 in my calculator. I didn't clear it, so I'm going to just subtract that £3.15, which is 1.2, which is £1.20 difference. So it's £1.20 less to post 3 large letters second class than first class. Part C, Gareth spent £15.95 posting large letters first class. How many letters did he post? Well, if that's the total that it cost him to post these large letters first class, we can divide this by the cost of a first class large letter and see how many he posted. So large letter first class is £1.45. So we're doing £15.95 divided by £1.45. Which is 11. So he posted 11 large letters first class. Part D, Lee has £3.50. Does he have enough money to post 5 small letters? Yes or no? Give reasons for your answer. So we're not ticking anything until we've done some working out and we've given reasons. Okay? So 5 small letters. Let's have a look at how much that would cost. Okay, so he could post them first class or second class. So let's find out how much it would cost to post them first class. So that's 5 times 95 pence, which I'm going to do 5 times £0.95, just so I'm working in pounds. 5 times 0.95. So it's £4.75. So he wouldn't have enough to post 5 small letters first class. Let's see if he'd have enough to post them second class. So that was 68 pence. So 5 times 68 pence, which is 5 times £0.68. So that costs £3.40. So he would have enough with £3.50 to post 5 small letters. So I'm going to say yes, but I have to give a reason. So if Lee posts them second class, he has enough. Question 2. Shape A is shown on the 1 centimetre grid. I'm going to highlight the fact that it's a 1 centimetre grid because that will help me if I need to give any information around measurements. So this is shape A. Part A, on the grid below, draw a square that has the same area as shape A. So we need to find out the area of shape A. Now, this is a rectilinear shape. It's a composite shape. So there is no quick area formula for us to work with, but we are given those centimetre squares. So if we count the squares inside the shape, that'll tell us the area, because the area is the space inside the shape. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So A has an area of 25 centimetres squared. So now they want us to draw a square that has the same area. Now what we need to remember about a square is that all four sides need to be the same. So if we had a square and we had side A, and all of the sides would be side A, but when we find the area, we do A times A, which is A squared. Okay, so I need to square root 25. Do that on your calculator if you don't know what it is. So the answer is 5. So the sides of my square need to be 5 centimetres. Now I'm going to draw this shape using a pen. I highly recommend you use a pencil in your exams, guys, just in case you make a mistake. So 3, 4, 5. 2, 3, 4, 5. Okay, so that's my square. All four sides the same. Has the same area as shape A. You can check it if you want to. 5, 10, 15, 20, 25 squares inside. Okay. Part B. Work out the perimeter of shape A. So we're going to go back to this shape here, shape A. We want the perimeter. So we've just dealt with area, which is inside the shape. The perimeter is all the way around the outside of the shape. And again, this centimetre grid is going to help us. So I'm just going to count how many centimetre squares around the outside. But I'm going to mark them because I need to make sure I count them all appropriately. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So the distance around the outside that shape is 24. So the perimeter is 24 centimetres. Okay, part 2 for B. On the grid below, draw a rectangle that has the same perimeter as shape A. So this time we're drawing a rectangle. We want it to have the same distance around the outside. So we're not looking at what's inside. We're looking at what's around the outside. So we want to have a perimeter of 24. Now if we think about here, just sketch really quickly. Things to remember about a rectangle. We don't have 4 equal sides. We have lengths and widths. But when we're doing the perimeter, it's 2 lengths plus 2 widths. So we need to remember that when we're trying to figure out what we want our length and width to be. So for example, if I said my width was 2, both widths would be 2. So that would be 2 plus 2 is 4. So if I do 24 take away 4, which is 20, I need my 2 lengths to add up to 20. So they both need to be 10. All right. Or you could potentially, if I do another one here, if I say my width is 3, this is also 3. 3 plus 3 is 6. 24 take away 6 is 18. So my 2 lengths have to add to 18, so they're both 9. So make sure you remember that when you're factoring in perimeter. I'm going to draw this one on that grid. So a 3 by 9 rectangle. There's a couple of different options you can use for these guys. So, but just make sure you're using the right set of numbers. So we've got 3, 6, 9. And it's a 3 by 9. So 3 plus 9 is 12, plus 3 is 15, plus 9 is 24. So it's going to match. Again, I drew my shape in pen so you could see it, but please in your exam, use pencil in case you want to change anything at the last minute. Question 3. A. Write the number 6,520,000 in figures. Okay, so we're going to write this numerically in figures using numbers. So we have 6 million. We have 520,000. So 520,000. You don't have to put those commas in. That's just habit for me. You could write that number without them, but you've got to make sure that it's the correct number. So we've got 6 in the millions, 520 here for the thousands, and then there's nothing, there's zeros after that because it didn't give us any hundreds, tens or units. Part B, shade 3/5 of the shape below. Okay, so let's check how many parts this shape is split into to start off with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I need to figure out how many of those 10 equal parts I need to shade in to make 3/5. So let's compare these fractions. To get from 5 to 10, remember we scale up with fractions, I would multiply by 2. So I'm going to do the same for the numerators. 3 times 2 is 6. So I need to colour in 6 of those equal parts. Any 6, it doesn't matter which. So 1, 2, 3, 4, 5, 6. Part C, rearrange these 5 boxes to create a calculation with an answer of 8. So we've got 4, 6, 24, add and divide, and our calculations are going to go in the boxes. So one of each of these in the boxes to get an answer of 8. Okay, so I know that if I'm aiming to get an answer of 8 and I've got a divide in there, I'm definitely going to be starting with my bigger number. Okay, so let's work this out. So let's go with, first of all, 24 divided by 4. 24 divided by 4 is 6, which leaves me with the plus 6. Well, if I add 6 to that, I get 12. I'm aiming for 8. So let's try the other option. 24 divided by 6. That's 4. And then I've got add 4 left. 4 add 4 is 8. So that works. So we have 24 divided by 6. And then add the 4. Part D. Write 465,784 correct to the nearest 10. Okay, so let's have a look at this. To the nearest 10. Units or ones, tens. So the 8 is in the tens column. The 4 next to it, okay, doesn't round it up to the next 10. It's going to stay the same. So it's 465,780. Remember that place now becomes a 0 once we decide whether or not we're rounding up to the next 10. So for the second part, correct to the nearest 1,000, well, we've got our units, tens, hundreds, thousands, and we look at the 7 next to it. Now that 7 is 5 or above. So that means that the 5 is going to go up to the next 1,000. So that's going to be 466,000. But the other place value columns become zeros. We've got to maintain the value of the highest place value, but also round accordingly. Question 4. 2 fair spinners are shown below, and them being fair helps us. It means we can read information from them and compare them. So we've got spinner A and spinner B. So part A, each spinner is spun once. Circle the expression that best describes the chance of each of the following events occurring. So the first event, spinner A lands on a circle. Okay, so we have 1, 2, 3, 4 circles out of 1, 2, 3, 4, 5, 6, 7, 8. So we have a 4 out of 8 chance it lands on a circle, which simplifies to a half. So that's an even chance. That's 50-50, guys. Part 2. Probability that spinner B lands on a square. Well, let's have a look at spinner B. There are no squares in spinner B, so that would be impossible. Part B. Spinner B is spun once. What's the probability that it lands on a star mark your answer with an arrow on the probability scale below. Okay, so we're dealing with spinner B and the probability that it lands on a star. So let's have a look. We have 1, 2, 3, 4, 5, 6, 7, 8 parts in total. And we have 1, 2, 3, 4, 5, 6 of them that are stars. So we need to represent 6 out of 8 on this probability scale. So let's check how many different intervals we have. So from 0, we've got 1, 2, 3, 4, 5, 6, 7, 8. Well, that's handy because they've already split it into the appropriate equal number of parts. So we want to find where 6/8 would be to mark our arrow. So starting at 0, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. So that's where I'm going to mark my arrow. A different spinner, spinner C, is spun once. The probability that spinner C lands on a star is 3/16. What is the probability that spinner C does not land on a star? Well, remember guys, probabilities sum to 1, okay? You can see that on the probability scale above. They go from 0 to 1. The highest probability can be is 1. So if we subtract 3/16 from 1, so 1 subtract 3/16. This is a calculator paper, guys, so I'm not going to make my head hurt with fractions. I'm going to put 1 subtract 3/16 into my calculator, which gives me 13/16. I've written that out because it's part of my working, because my examiner's not going to see my calculator, but I entered it into my calculator to do the maths. So the answer is 13/16. Question 5a, calculate the value of x. So we have a straight line here, we've got the angle marked, and it says that the angle is 3x degrees. Tells us that our diagram's not drawn to scale, so we can't measure anything directly from the diagram, but also the fact that it says calculate is a big hint that we can't do that as well. All right, angles on a straight line. Angles on a straight line add to 180 degrees. So this whole angle here is 180 degrees, which means 3x is equal to 180 degrees. So I can now solve this one-step equation to calculate the value of x. So remember, 3x is 3 multiplied by x. The inverse of multiplying would be to divide. So 3x divided by 3 gives me x. Do the same on both sides, guys, to balance that equation. 180 divided by 3 is 60. I knew that. You could do it on your calculator if you needed to, guys. Part B, calculate the value of y. So here we've got another diagram, not drawn to scale. We've got a right angle here, and I know that a right angle is 90 degrees, so I'm going to label that. And then we've got this other angle here, labelled 5y. Now what the right angle and this other angle form are a full circle, angles around a point. So that whole thing should be 360. So to find 5y, I can take 360, take 90 away from 360. So do it on your calculator. It's 270. So this angle here is worth 270, which means 5y is equal to 270. So now we can solve for y. We've got a one-step equation. 5y is 5 multiplied by y. The inverse of multiplying by 5 would be to divide by 5. 5y divided by 5 is y. And then we're going to do the same to the other side to balance this fraction. 270 divided by 5 is 54. So y is 54 degrees. I'm going to put degrees on x as well, just to be safe. Question 6. A, B, C, D is a kite. So A, B, C, and then another point D would form a kite. 3 of its vertices have been plotted on the grid below. So that word vertices means the corners. So 3 of the corners for that kite have been plotted. So A, B, and C. Part A, plot point D on the grid to complete the kite. Okay, so things we need to remember about a kite. From the top, between the top 2 vertices, that line there is a line of symmetry. So D needs to be the same distance from A that B is, and the same distance from C that B is. So let's plot the journey from A. So to get to B, we go down 1 and across 2. So to get to D, we're going to go down 1 and across 2 in the other direction. So that's where D should be. So that's part A. Part B, write down the coordinates of point D. Okay, so for coordinates, we write the x coordinate first. So for D, the x coordinate is 1. And then we write the y coordinate. Well, if we read across, the y coordinate is 4. Part C, draw a reflection of the kite ABCD in the x-axis. Okay, so we're going to reflect it in the x-axis. So we're going to reflect it over this line. Now, you can just reflect the points, or if you want to, you could draw on the sides so you can visualise the shape itself. You'll be used to seeing reflections of a shape rather than coordinates, so that might be useful. So we're reflecting it across the x-axis, so let's take it a point at a time. So point C is 1 away from the x-axis, so we're going to put it 1 away on the other side. D is 1, 2, 3, 4, so we're going to go 1, 2, 3, 4. B is 1, 2, 3, 4, so we go 1, 2, 3, 4. And then A is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's finish that shape to make it nice and clear. There we go. Question 7. The graph below shows the average maximum daily temperature in degrees Celsius and the average monthly rainfall in millimetres in Greece. So we've got a key here. So the temperature, the average temperature are the bars and the average rainfall are the line graph. Part A. Which month has the highest rainfall? So for rainfall, we're looking at the line graph and we're looking for the highest point that is plotted. So the one that's highest up there, because this is the frequency axes. So if we look, it's this point that's the highest. And if we look at where that matches up to, well, that matches up to November. So November had the highest rainfall. Part 2. Calculate the difference in average maximum daily temperature between the warmest month and the coolest month. So we're working with temperature, so that means we're looking at the bars now, guys. We want to look for the average maximum daily temperature between the warmest month and the coldest month. So we want the highest bar for the warmest month and the lowest bar for the coolest month. Well, the highest bar is clearly August. So let's read across what that value would be. So that would be there. So if we look at this scale, 30 to 40 is 5. So that must be 2 each, so 32, 34. So the highest temperature, the warmest month was 34. The coolest month is the smallest bar, which is this one, in January. And that bar takes us to there, which must be 12. So we're going to do 34 subtract 12. You can do all of your calculations on your calculator if you want to, guys, as long as you write them out. And then we've got 22 as our difference. Okay, part 3. Courtney wants to go on holiday to Greece. She does not want the average maximum temperature to be over 30. So she wants it to be less than 30 degrees temperature wise, and she hopes for as little rain as possible. Which month would be the most suitable for Courtney to go to Greece? So we're looking at the months that have a temperature bar less than 30. So if we see where 30 is, and if we draw a line where 30 is, that's our cut-off point. So she wants below that line in temperature, but she wants the lowest possible rainfall that she can get. So we're going to look for the lowest point on this line graph that's below that line at 30, which is going to be there. Well, August, that's the lowest point, but August bar's over 30, isn't it? So we're going to discount those two. So the next lowest is this one. The bar's below the 30 line. So we'd say the best month for her to go would be June. Part B. The formula shown below can be used to convert between temperatures in degrees Fahrenheit and temperatures in degrees Celsius. So we've got this formula, F equals 1.8 C add 32. On a particular day in Greece, the temperature was 25 degrees Celsius. Use the formula to convert this temperature to degrees Fahrenheit. So this formula works out degrees Fahrenheit, and we've been given a temperature in degrees Celsius, which is C. So we're going to write out this formula, but we're going to substitute 25 where C is. So that's 1.8 multiplied by C, so 1.8 multiplied by 25, but then we've still got to add that 32. And we can put this all in our calculator. So 1.8 multiplied by 25, that's why brackets are useful in your calculator, guys. Add 32, so it's 77 degrees Fahrenheit. Question 8. Alex and Louise buy some cereal bars and drinks at a shop. The image below shows the items that Alex and Louise bought and their total cost. So Louise bought 4 cereal bars and it cost £5. Alex bought 1 cereal bar and 3 drinks and it cost £5.60. Assume that each cereal bar is identical and each drink is identical. Okay. Find the cost of 1 cereal bar and the cost of 1 drink. Okay, so we're going to start with what Louise bought and spent because she bought the same thing. So for 4 cereal bars, it costs £5. So if we do 5 divided by 4, that tells us that it was £1.25 per cereal bar. And I'm going to put £1.25 there, ready. We now need to figure out the cost of 1 drink. Well, Alex is the only person that bought drinks, so it's his shopping that we're going to have to work with. He bought 1 cereal bar, but then 3 drinks, and it cost £5.60 in total. So we know that a cereal bar is £1.25. So if we take that £1.25 from his total, so 5.6 take away 1.25. So that's £4.35. So that £4.35 is for those 3 bottles. So we can now divide that by 3 to find the cost of 1. So one of them costs £1.45. So we're going to put £1.45 on the bottom for drinks there. Question 9. The manager of a shop calculates the wages of her staff at the end of each week. She uses this diagram. So we've got a function machine here. So you put the number of hours worked in, you multiply it by the hourly pay, you add the bonus, and then that gives you their total wage. And then in this table, we've got hourly pay rates. So a junior sales assistant gets paid £10.42. A senior sales assistant gets paid £11.50. Part A. Hamza is a junior sales assistant. Last week, he worked for 25 hours and had a bonus of £80. What was Hamza's total wage last week? So we're going to use this function machine to work out his total wage. So we need the number of hours worked first. So 25 hours worked. We multiply that by his hourly rate of pay. Well, he's a junior sales assistant, so that's £10.42. Once we've done that, we then add the bonus. Well, the bonus is £80. And then that would tell us his total wage. So because I've put that bracket there, that means I can put all of this in my calculator at once. If I didn't put the brackets, it wouldn't necessarily do them in the right order for me. So let's put the brackets in. 25 times £10.42 plus 80. So he earned £340.50 that week. Julie is a senior sales assistant. Last week her total wage was £271, including a bonus of £64. How many hours did Julie work last week? So this time we're starting with the total wage. We're working backwards to the number of hours worked. So this is a function machine, but when we work backwards, we do the inverse operation. So For the total wage, instead of adding the bonus, we would subtract it. Instead of multiplying by the hourly rate, we would divide it. Okay, so total wage is what we're starting with. So 271, a bonus of 64. Remember, when we're coming this way, we're doing the opposite. So instead of adding the bonus, we're going to take the bonus away. So that's 207. And then at this point, got 207, so we're going to divide by the hourly rate of pay. So Julie is a senior sales assistant, so it's £11.50. So 207 divided by £11.50, which is 18. So she worked 18 hours that week. Question 10. Jared won £3,000 in a competition. Part A, he spent £500 and gave 37% of the remaining money to charity. This was shared equally between 5 different charities. How much did each charity receive? Okay, so first of all, let's take away the £500 that he spent. So he started with 3,000 and we're taking away 500. 2,500. So 2,500, he gave 37% of that to the different charities. Okay, so we need to find 37% of 2,500. Now, because it's a calculator paper, I'm going to use a decimal multiplier. So if I want 37%, that is the same as 0.37 as a decimal. Okay, so I'm going to do 2,500 multiplied by 0.37, which is £925. So this is how much he shared between the charities. There were 5 different charities, so we're going to divide that by 5. So he gave £185 to each charity. Part B, Jared saved £600 of the 3,000. What percentage of the 3,000 does Jared save? So he's saving 600 out of the 3,000, but then we'd want to convert that to a percentage. So when we convert a fraction to a percentage, we multiply by 100. So now I've written that out. I'm just going to put that in my calculator. 600 over 3,000 multiplied by 100. Which is 20, so he saves 20% of the 3,000. 11A, simplify each of the following. So part 1, we have A, add 7B, add 5A, minus 9B. So this is collecting like terms. So we've got A, add 5A. Remember, it's important that the symbol in front, the add or the subtract, stays with the thing that it's attached to. So A, add 5A. So A, add 5A. Well, that's 1A, don't forget. So 1 of them plus 5 of them gives me 6 of them. Now we're going to collect the B terms together. So remember, for them to be like terms, they have to have exactly the same letter and exactly the same power. So this time we've got positive 7B. Subtract 9B. Remember, that sign in front stays with it. So we've got 7B subtract 9B. Now 7 of them take away 9. If you're not great with your negatives, just do 7 take away 9 in your calculator. Look, -2, but don't forget the B. Now we have to write this as an expression. So I'm going to write my X term next to my B term. Remember, that minus stays with that 2. Part 2, we have 6W divided by 2W. So 6W divided by 2W. Well, 6 divided by 2 is 3. W divided by W, they cancel out. So our answer is just 3. Part B, Amanda buys 5 bags of apples. Each bag contains n apples. She gives away 2 apples from each bag. Write an expression for the total number of apples Amanda has left. Okay, so the total number of apples she starts with are the 5 bags containing n each. So we have 5 multiplied by n. So 5n is her total. but she gives away 2 apples from each bag. So we're taking away 2 apples from each of those 5 bags. So 2 times 5. 2 times 5 is 10. So our expression would be 5n subtract 10. Question 12. The Cowell family are planning a holiday to Spain for 7 days. They can either pay for a package deal or pay for return flights, accommodation and food separately. All of the costs are shown below. So here we've got the information about a package deal. So it's £2,300 for a 7-day holiday to Spain for a family of 4. Return flights, accommodation and food are all included in that cost. Okay, so return flights, accommodation and food all included in that cost. Pay separately. So return flights, accommodation and food are free for children under 2 years old, but then for everybody else, return flights cost £350 per person, £43 per person per day for accommodation, and then £85 per person for 7 days for food. So on the holiday, there will be 2 adults and 2 children. So this is a family of 4, isn't it? So family of 4 works here. They each require return flights, accommodation and food. The Cowell family wish to choose the cheaper option. Which option should they choose? The package deal or pay separately? Show how you decide. So we are not ticking a box yet. We're going to do some working out first. So 2 adults, 2 children, so a family of 4. So this package deal, this 2,300 has everything included that they want. Flights, accommodation and food. Flights, accommodation, food included, 7 days for a family of 4. Okay, so that's 2,300. So what we need to do is work out how much it's going to cost if they pay separately. Now what we need to remember here is return flights, accommodation and food are free for children under 2 years old. Well, the children are aged 8 and 1 years old, so one of those children is under 2, so they're not going to have to pay anything for them, which is wonderful. So they're only paying for 2 adults and 1 child. So when we're working with this, we're working with 3 people, not all 4. So let's figure out the flights. So for 3 people, the flight's £352 per person. So 3 times 352. So that's £1,056 for the flights. Accommodation. So it's £43 per person per day. So it's £43 per person. There's 3 of them per day for 7 days. So 43 times 3 times 7. So that's £903. Then we need to work out their food. So it's £85 per person for the 7 days. So it's just a one-off payment. So £85 per person. Well, there's 3 people that we have to pay for. 85 times 3 is 255. So let's find the total cost. 255 is already in my calculator. Add 903. Add 1,056. So that's 2,214. So the package deal is 2,300. Pay separately is 2,214. Well, 2,214 is less than 2,300. So this is the cheaper option. So paying separately is the cheaper option. Question 13a. 3 fair coins are thrown at the same time. Part 1. Complete the table to list all the different possible outcomes. The first row has been completed for you. Okay, so if we're throwing 3 coins, the first option is that all 3 coins land on heads. So you need to just be really systematic with this question and have some kind of pattern in mind for how you're going to fill this out. Okay, so the first 2 could be heads and the last one could be tails, or first could be heads, middle could be tails, last could be heads. Okay, now I'm going to start with tails. I could have tails, head and head. I could have heads and then 2 tails. I could have tails, head, tails. Or I could have tails, tails and head. Or they could all 3 land on tails. So just have some kind of strategy on how you're working. You can see here, I kind of worked in a diagonal with my t's a little bit until I needed to figure out the other combinations. Part 2, write down the probability that the outcome is 3 heads. Okay, so only one of these options is 3 heads. So we have 1 out of 1, 2, 3, 4, 5, 6, 7, 8. So we have a 1 out of 8 probability that it would be 3 heads. Part B, when 4 fair coins are thrown at the same time, the probability, so we've got 4 coins here, the probability that the outcome is 2 heads and 2 tails is 0.375. If the same 4 coins are thrown 136 times, how many times would you expect to get the outcome of 2 heads and 2 tails? Well, 2 heads and 2 tails is the probability that they've given us, so that's handy. If we do this 136 times, we do 136 times the probability of the event happening. So 136 times 0.375. So we'd expect that to happen 51 times. 14a. The amount of electricity and gas used in a home is measured in units. In the first week of May, the Singh family used 56 units of electricity and 245 units of gas. The cost per unit of electricity is 32 pence. The total cost of the units of electricity and gas the Singh family used in the first week of May was £39.97. What is the cost of 1 unit of gas? Okay, so we have 56 units of electricity. Each of them costs 32 pence. So I'm going to do 56 units times that 32 pence, which is 1,792 pence, which is £17.92. So it costs them £17.92 for those 56 units of electricity. Okay, they used 245 units of gas. But the next piece of information we get is the total cost for electricity and gas. So the total cost for electricity and gas was £39.97. So I'm going to take this, the cost of electricity, away from £39.97. So £17.92. So £39.97 subtract 17.92. So this tells me that the total cost for gas is £22.05. Now they did 245 units, so I'm going to divide £22.05 by 245, which is £0.09 or 9 pence. Doesn't matter which way around, but that's how much per unit of gas. So I'm just going to put 9 pence on the answer line. Part B. The Singh family are calculating their electricity bill for the 30 days of June. They used 210 units of electricity in June. The cost per unit of electricity is 32 pence. They pay a fixed charge of 28 pence per day, and VAT at 5% is added to the total of these costs. Calculate the total cost of the Singh family's electricity bill for June. Okay, so we've got 210 units of electricity at 32 pence. So let's start there. 210 times 32. So that would be £67.20 because that's 6,720 pence. Okay. They also pay 28 pence per day and there's 30 days in June. So we're going to do 30 times 28, which is £8.40. Okay. We're going to total that up now, guys, because this will be their total bill. So add the £67.20. So we have a total of 900. I've pressed something wrong there. Oh, I know. I didn't change it to pounds, did I? That is a more reasonable price. What was I thinking? Okay, £75.60. So that's the total cost, but they pay VAT of 5% on top. So we need to find 5% of that total and then add it on. So because there's a calculator paper, again, I'm going to work with a decimal multiplier. So 5% is 0.05. If you don't know how to get a decimal multiplier, if you just divide the percentage by 100, you're going to get a decimal there, guys. And that's your decimal multiplier. So I'm going to do £75.60 multiplied by 0.05. Which is £3.78. So we need to add that to their total. So £75.60 plus the £3.78, which is the VAT. So we have a total cost of £79.38. So the total cost for electricity for the Singh family was £79.38. Question 15. Rhiannon cycled from home to a park. She cycled 15 miles along a straight road. The graph shows her journey. So this is the distance she is from home. So this is at home. This is the time taken. Part A. On her journey to the park, Rhiannon had a puncture. How long did Rhiannon stop to repair the puncture? Now, if she had a puncture, she stopped, then we're looking for any parts of the graph that are horizontal. So this is travelling, stopped, travelling and stopped. So on her journey to the park, she got a puncture. So we're dealing with this part here, okay? Because 15 miles along a straight road, that's when she got to the park. So we're going to read down from where this line starts to where this line ends. So it ends at 10 o'clock, but it starts here. So that would be 9:45. So each of these are worth 3. So 3, 6. So that's 9:36. So from 9:36 till 10 o'clock is 24 minutes. So it took her 24 minutes to repair that puncture. Part B. Rhiannon was on average travelling faster before she had a puncture than after she had a puncture. Without calculating any speeds, explain how you can tell this from the graph. Well, this section of the graph is before she had a puncture, and then this section of the graph when she's travelling is after the puncture. Now, the orange line at the start of the journey, so before the puncture, is steeper, and that's how we know she was travelling faster. So we can simply say, before the puncture, the line was steeper. Part C. Rhiannon left the park at 11:30 and cycled back along the same road to a friend's house that is 5 miles from her home. This journey took 45 minutes. Draw this journey on the graph. Okay, so we're going back to this graph here, guys. So she's travelling, here she's at the park. She's travelling from the park to her friend's house, but her friend's house is 5 miles from her home. So she's not going all the way home. She's only going to the point where she's 5 miles away. So that's important to note. It says that this journey took her 45 minutes. So from here, from 11:30, 45 minutes would be at 12:15. She's only travelling to 5 miles away from her house. So this is where her friend's house is. So that we're going to join that line onto the graph there. I did it in pen, guys, so you could see it nice and clearly. Obviously, please do it in pencil in case you need to rub it out. Okay. Part 2. Calculate the average speed of Rhiannon's journey from the park to her friend's house. Give your answer in miles per hour. So we're calculating the average speed of this part of the journey. Okay. So speed is distance divided by time. So let's see what, if we're working out speed, we want distance and we want time. So let's have a look at this graph. So here she was 15 miles away from home, but here she's 5 miles. So the distance was 10 miles. 15 subtract 5 is 10 miles. The time, well, they tell us the time. It took 45 minutes. But when we're calculating with speed, distance and time, we don't want our time in minutes, we want it in hours. So that is 45 out of 60. So that's 45 out of 60 minutes in an hour. If you put that into your calculator, well, you could work with that as well, but it will simplify it for you. So we're working with 3/4 of an hour. So speed is distance divided by time. So to work out her speed, we're doing our distance of 10 divided by our time of 3/4. So 10 divided by our time of 3/4, which is 13.3. Don't forget the recurring symbol because that 3 continues. Question 16. This is a map of a holiday park. So this is our holiday park and we've got some landmarks noted on there. Part A, measure and write down the bearing of the reception from the park entrance. So we're working with the reception and the park entrance. So the first thing I'm going to do is I'm going to draw a line between them because that helps me when I start to use my protractor. We are using a protractor because it tells us to measure. It doesn't tell us that the diagram's not drawn accurately. It tells us to measure. So we want the bearing of the reception from the park entrance. So we're starting at the park entrance. These north lines are really handy. If we didn't have those, we'd have to draw them because we measure bearings from north in a clockwise direction. Okay, so the bearing of the reception from the park entrance is this angle here. Okay, so you can either measure that whole angle, but bearing in mind I don't have a full protractor, I only have half of one. I'm going to measure this little angle in here and then use it to calculate that angle. Okay, so first thing I'm going to do is I'm going to measure this angle, and that's why I drew this line. Now my protractor's not the best for this. Yours will be better in school because they have 2 rows of numbers. You have an inside row and an outside. I don't. Anyway, so we're lining up this centre mark on your protractor with this point here. So we're lining it up, and then this line is getting lined up so that it's parallel and flush on my north line. And then I'm going to start here and I'm going to read that angle around to that line that I've drawn. Now for me, I'm going to have to count backwards because I'm starting at 180. So that's 10, 20, 30. So this is 30 degrees. I'm sure your protractors will be a little bit less weird than mine. So if this is 30 degrees, this whole angle around this point at the park entrance must equal 360. So 360 subtract 30 is 330 degrees, and that's our bearing. Now, point to note on bearings, guys, they have to be 3 figures. So if I was writing 30 as my bearing, I have to write 0, 30. But luckily, my answer is in 3 figures. Part B. Amir is camping at the holiday park. His tent is on a bearing of 0.25 degrees from the park entrance and 280 degrees from the park exit. So we want a 25 degree angle from the park entrance and a 280 degree angle from the park exit. And then once we plot those angles, we need to mark with a T the position of his tent. So it's 25 degrees from here and 280 degrees from here. So the first thing I'm going to do is I'm going to plot my 25 degrees from the park entrance. So remembering this centre part of your protractor goes on the point that you're measuring your bearing from. The line goes on your north line, nice and flush. I'm starting at 0 here and I want to go to 25. So 25 is there. So I'm going to make a really clear mark. Okay. And then I'm just going to, from my park entrance, through that line, that mark I've just made, I'm just going to draw a line. Again, I'm using pen so you can see it nice and clearly. In your exams, use a pencil, guys, please. Now, we need 280 degrees from the park exit. Now, again, I don't have, if you have a protractor that goes all the way round, fantastic, lifesaver. You can just stick that on and you can go all the way around to 280. Mine doesn't. But what I do know is that straight down, that would be 180 degrees. So if I want to go 280, I only need to go another 100 from that line. So I'm going to put my middle point of my protractor on the point that I'm measuring from. This line is going to go flush with that line I've just drawn to identify my 180 degrees. And I want to go round another 100. So 100 is here. So I'm going to make a mark there. Once I've done that, I'm going to join my park exit point and the point I made for 280 degrees. Now you'll see that they intersect. It's good that they intersect because that's exactly the point where Amia's tent is going to be. So we're going to label that T. Question 17. The universal set contains the numbers 4, 9, 12, 18, 23, 32, 50, 64 and 72. S is the set of square numbers. F is the set of factors of 36. Part A, show this information in the Venn diagram below. So we've got to complete this Venn diagram. So the first thing I'm going to do, this is the universal set, so the overall set. I'm going to figure out what are in these sets because we need to find out what's going to go in the square numbers circle, what's going to go in the factors circle, and what's going to go in the middle because it's in both the square numbers and the factors of 36. So I'm going to identify the square numbers from this list. Now, if you're not comfortable with your square numbers, just go ahead and square root all of these. So square root of 4 is 2, so 4 is a square number because it gave me a whole number. Square root of 9 is 3. So 9 is a square number. Square root of 12 is not a whole number, so it's not a square number. Square root of 18, again, and keep going. But I know that the other square number up there is 64. We want factors of 36 now. So 1 and 36, 2 and 18, 3 times 12, 4 times 9, and then it would be 6 times 6. So is 4 in that list? Yes. Is 9 in that list? Yes. Is 12 in that list? Yes. 18? Yes. 23? No. 32? No, and the rest of them are too big. So these are my square numbers and these are my factors of 36 that are in that list. Now we're going to identify any they have in common. So we have 4 and 4, 9 and 9. So 4 and 9 go in the middle of our Venn diagram because they are square numbers but also factors of 36. Now in the square numbers circle in this section here, we're going to put 64 because that's the square number that's left. And then in this section of the factors of 36, we're going to put 12 and 18 because that's the numbers that are left. So we've got 4, 9, 12, 18 and 64. These numbers still need to go in the Venn diagram, but they go on the outside because they don't belong in the square numbers and they don't belong in the factors of 23. So, factors of 36, sorry. So 23, 32, 50 and 72. So that's your Venn diagram complete. Part B. A number is selected at random from the universal set. Find the probability that the number selected is a factor of 36, but not a square number. Okay, so if a number is selected at random from the universal set, it's selected at random from here. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our probability is going to be out of 9. Alright, we want the probability that it's a factor of 36, so it's in this circle, but it's not a square number, so it can't be in the middle. So we've got 1, 2, so the probability is 2 over 9. Question 18. The grid below shows triangle A and triangle B. Question A. Describe fully the single transformation that maps triangle A onto triangle B. So from A to B. Okay, so the first thing I can say here, it's not an enlargement because the shape hasn't changed size. It's not a translation, because if it was a translation, then the shape would be exactly the same orientation as A. It would have just moved to the side or up or down. So this is either a reflection or a rotation. Now this is a rotation because you can quite clearly see that it's the shape itself, it's just changed orientation. It's turned around a little bit. So the first thing I'm going to write is rotation. Okay. And then what I'm going to say is this point here matches this point, and this point here matches this point. So actually, it's turned 90 degrees. So if we've gone from here, we've turned 90 degrees clockwise. We now just need to say what the centre of rotation is. So we need a coordinate. And I'm going to use tracing paper to help me with that, guys. Okay. So I'm going to draw shape A. Now remember from the previous videos that I've done, there should be tracing paper in your maths pack on your exam desk. If there isn't, stick your hand up, ask for some, they will have it, and you are entitled to use it. I'm going to use a different pencil because this probably won't rotate very well. Okay, so I know that it's moved 90 degrees in this direction, so I'm just going to pick a point. So let's imagine it was rotated around this point. So if I move that triangle, so it's not quite made it into the right place. I'm too low, I'm too high, and I'm not far enough across that way. Okay, so let's try here. 1 0, sorry, I can't even do coordinates today, it seems. Okay, so this one is getting lower, it's getting closer. All right, let's shift across a little bit more. So we're going to the origin here. So put it on, nice and tight. Ah, look at that, it matches. So that was on the origin. So the centre of rotation is coordinate 0, 0. Part B, translate triangle A using the vector -3, 2, and then label it C. So we're working with triangle A here and we're translating it. So we're not rotating it or anything, we're just moving it according to what this vector tells us. So that -3, so on the top we move left or right. If it's a negative, we move left. So we're going to go 3 places to the left. So we go 1, 2, 3, okay? The bottom is up and down. Negative would be down, positive would be up. So we're going 3 places to the left, 2 places up. So we're going to take each point. We're going to go 1, 2, 3 to the left, 1, 2 up. 1, 2, 3 to the left, 1, 2 up. 1, 2, 3 to the left, 1, 2 up. And then we're going to draw that shape. And don't forget it says to label it C. So let's label it C. Question 19. Shortbread biscuits are made from flour, butter and sugar. Their masses are in the ratio 4:3 to 2 respectively. So flour, butter, sugar, 4:3 to 2. I always make little notes like that in the ratio to make sure I remember which section of the ratio relates to what. Part A, what fraction of a shortbread biscuit is made up of sugar? So for a fraction we need a total number of parts. So the total number of parts for our ratio is going to be 4 plus 3 plus 2, which is 9. We're interested in the parts that are sugar. Well, this is sugar here, so it's 2 of those 9 parts. Part B, 1,400 grams of flour is used to make a batch of shortbread biscuits. How many grams of butter is used for this batch of shortbread biscuits? So we're going to use this ratio from here. So flour, butter, sugar. And it's a ratio of 4:3 to 2, okay? So it tells us that it's 1,400 grams of flour. They want us to know how many grams of butter. So we're interested in what this part of the ratio would be. Now remember, when we're working with ratios, we scale up or down, we multiply or divide. So I'm going to figure out what I need to do to this ratio to get here. So I'm going to do 1,400 divided by 4. Which is 350. So what I've done is I've multiplied by 350. So to find the amount of butter, I'm going to do 3 multiplied by 350, which is 1050. So it's 1050 grams of butter. Question 20. Lucy bought a car 9 years ago for £12,250. The car depreciated in value by 18% in the first year. In each of the following years, her car depreciated by 15% of its previous year's value. By how much has the car decreased in value in the last 9 years? So we've got a couple of steps here. We've got how much it depreciated in the first year, and then how much value it lost in the remaining years. Okay, so let's start with the first year. So we had a starting value of 12,250. It depreciated by 18%. So it started at 100% of its value and it depreciated by 18%. So that is 82%. Now 82%, if I divide that by 100 as a decimal multiplier, is 0.82. I'm going to work with decimal multipliers because I've got a calculator, so I might as well. So I'm going to multiply by 0.82. So 12,250 multiplied by 0.82. So at the end of the first year, the value of the car was £10,045. Okay, for the remaining years, so from 9 years, so for the remaining 8 years, it depreciated by 15% of its previous year's value. So depreciating by 15%, so 100%, its cost at that time, take away 15% is 85%. 85%, if we divide that by 100, is 0.85 as a decimal multiplier. So we've got the value at the end of the first year multiplied by 0.85, but this time it's compound depreciation, okay, works the same as compound interest. This is happening for the remaining years. This was the first year, so we've got another 8 years. So we have to raise that to the power of 8. So 10,045 times 0.85 to the power of 8, which is £2,737.17. So that's how much the car's worth after 9 years. We want to know by how much it's decreased in value. So we want to know the difference from what it was to start off with and what it's worth after the 9 years. So 12,250 subtract its value after 9 years. So it's gone down in value by £9,512.83. Question 21. Regan caught 70 fish on a fishing trip. He measured the length of each of the fish in centimetres. The table shows his results. So we've got the range of lengths, the number of fish that fell within those ranges. Part A, calculate an estimate for the mean length of the fish. Okay, so we need to add some columns in here, guys. So we need our midpoint column. And then we're going to do our midpoint multiplied by our frequencies. So our midpoint is halfway between these two values. So add them together, divide it by 2. Okay, add them together, divide it by 2. And then I know the rest of them, but you could just add them together and divide it by 2 if you want to. Make sure you write your decimal points clear here, so when you do some calculations later, you don't forget that they were decimals. That's what some people do. And then that's 82.5. So now we're going to multiply the midpoint by the frequency. So we've got 62.5 times 19. So that's 1187.5. 67.5 times 17. 1147.5. 72.5 times 23. 1667.5. 77.5 times 10. And then 82.5 times 1 is just 82.5. So now we need to total those up, guys. So we've got a new frequency midpoint total. So 0.5 plus So that's 4,860. So now to estimate the mean, we do 4,860 divided by the total number of fish, which they very kindly told us at the start is 70. So it's the total divided by how many we have, which is 69.42857,143. You can round it if you want to, but it doesn't ask you to. So let's just say 69.4 centimetres because we were working in centimetres. Okay, part B. Regan thinks that the median length of fish is in the group 70 to 75. Is Regan correct? Give the reason for your answer. Okay, we're not ticking a box yet. We're going to find out what the median length is and decide if he's correct. So to find the median, we have 70 fish in total. The median is the middle point, but it works slightly different with tables, okay? So we're going to divide the total number of points by 2, which is 35. So then we're going to do a cumulative total here, guys, to find out where that 35th fish would be. Okay, so we're going to start with 19 plus 17. So 19 plus 17 is 36. So once you go past 19, from 20 to 36, fishies are in here. Okay. Well, we're interested in the 35th fish. So it's got to be in this group here. So he's wrong because the median is, and then write the correct median group. So 65 is less than or equal to L is less than or equal to 70. Question 22. Jan has a large piece of card. The card has width 60 centimetres and length 96 centimetres. So this is the card here. Width 60, length 96. She uses a machine to cut identical circles out of the card, and each circle has a radius of 6 centimetres. So these are the circles she cuts out. Diagram not drawn to scale, so we can't just measure anything directly from it. Jan has cut 5 circles, as shown in the diagram above. She continues in this way to cut as many circles as possible from the card. Part A, what is the maximum number of circles Jan can cut out of the card? Okay, so let's think about these circles. The radius is 6, so all the way across the diameter must be 12 because it's double. So each of these circles has a diameter of 12. And it would work the same way down this way as well, obviously. So what we can do is we can do 96 divided by 12. Which is 8. So we would fit 8 circles along. But then we can do 60. So that's the width. Divided by 12. Which is 5. So we'd have 8 circles along and 5 circles down. So the maximum number of circles would be 8 times 5, which is 40. Part B. Jan cuts out the maximum number of circles from the card. What area of the card is left over? Okay, so if she cuts out 40 circles maximum, okay, she's going to cut out 40 of these circles. So 40 times by pi times 6 squared. Pi times radius squared is the formula for a circle. So she would cut 40 lots of that out. So let's work out what that would be. 40 times pi times 6 squared. I'm going to leave it in terms of pi so I don't have to type in a load of decimals later. Okay, so she's going to cut that area of circles out of this rectangle. So we need to find out what the total value of the rectangle is. So we're going to do 96 times 60. So that's 5,760. So that's the total area. That's the area she cuts out. We're interested in what's left. So we want the difference between those. So we're going to subtract them from each other. So 5,760 subtract 1,440 pi. So 5,760 subtract 1,440 pi is 1236.106579. It doesn't ask us to round it, but I'm going to put 1236.1 centimetres squared on my answer line. Question 23A, expand and simplify. So for this one, I'm going to use a grid. Hopefully you'll have seen this as an expansion method before. So x plus 3 is one of the brackets, x plus 7 is another. So this is a multiplication grid. So in this one, we're doing x times x, which is x squared. In this box, we're doing x times positive 7, which is positive 7x. In this box, we're doing positive 3 times x, which is positive 3x. And then in the bottom corner, positive 3 times positive 7 is positive 21. Now I've got my x squared term and I've got my plus 21. I now need to collect like terms with the x terms. So we've got positive 3x plus another 7x, so we would have positive 10x as well. Part B, solve 7x plus 6 equals 4x plus 7. So 7x plus 6 equals 4x plus 7. So the first thing I'm going to do is eliminate the smallest lot of the variable that we're looking for. We've got x on both sides. I don't want that. So I'm going to eliminate the 4x because it's smaller than 7x. This is a positive 4x. I know it's a positive 4x because there's no negative sign in front of it. So I'm going to take away 4x from both sides. 7x take away 4x leaves me with 3x. I've got the plus 6. 4x take away 4x eliminates it, so I've got the 7 here. Now I've got a two-step equation. I'm trying to isolate x, so I'm going to, instead of adding 6, the inverse would be to subtract 6. So we have 3x equals, and when I subtract 6 on this side, because I need to balance the equation, 7 subtract 6 is 1. And then my last step, divide by 3, because 3x is 3 multiplied by x, and the inverse of multiplying by 3 is to divide by 3. 3x divided by 3 is x. 1 divided by 3 is 1 over 3, and I'm going to leave it as a fraction. Part C, factorise. Y squared subtract 400. This is the difference of two squares, guys. We still need two brackets because we have the squared term and the number term. Okay, so we still need two brackets. Each bracket is going to have a y in it. Y times y is y squared. But then in each bracket for the number, we need the square root of 400. So the square root of 400 equals 20. So we're going to put 20 in each bracket. We need it to be a negative 20, so we're going to get a positive and a negative to make sure we get a negative 400 at the end. Part D, solve the following simultaneous equations. You must show all your working out. Okay, so the first thing I do with simultaneous equations is I look to see if I have any matching variables. So does the coefficient of the x and the y's match? No, none of them match at the minute. I've got 7x and 1x. I've got minus 3y and plus y. So I'm going to make them match. So I'm going to multiply this equation by 3. X times 3 is 3x, y times 3 is 3y, and then 3 times 3 is 9. Remember to multiply everything in that equation. Now I'm comparing these two. And I do have matching coefficients. I have 3y and 3y. So now I need to decide whether I add or subtract these equations to eliminate a variable. So looking at those signs, we've got a negative 3y and a positive 3y. The signs are different, so we need to add so that we eliminate y. 7x add 3x is 10x. Negative 3y add 3y cancels out our y terms. 26 add 9 is 35. So we've got a one-step equation here that we can solve. 10x is 10 multiplied by x. The inverse of multiplying by 10 is to divide by 10. So 10x divided by 10 is x. Do the same on both sides to balance the equation. So 35 divided by 10 is 3.5. So x is 3.5 on our answer line. Now that I know x, I can calculate y, and I'm going to use this equation here. So we have x plus y equals 3. I know that x is 3.5, so 3.5 plus y is equal to 3. Now I'm trying to isolate y, that's the value I need to know, so I'm going to subtract 3.5 from both sides, which gives me y equals 3 subtract 3.5 is minus 0.5. Do that on your calculator if you need to, guys. So y is minus 0.5. Question 24. The two shapes below are similar. So we've got this shape with some measurements, this shape with some measurements, they're similar. So they have a relationship. Diagram not drawn to scale, so we can't measure anything directly from it. Find the value of r and the value of t. Now if these two shapes are similar, it means they will have a scale factor. Okay, so a scale factor in common. So we're going to find the linear scale factor because we're dealing with lengths. We've not got anything for area or anything like that. So we need to identify a corresponding length on each shape. So we're going to go with this length and this length because they are corresponding, they have a relationship. So to find the scale factor, I'm going to do 15.6 divided by 10.4. Which is 3 over 2, which is 1.5. So that's our scale factor. Find the value of r and the value of t. So let's look at r. So r equals, now r, when we look at it, corresponds to this side, okay? So if we get the smaller side of 7.6 and we multiply it by our scale factor of 1.5, that will tell us what r is. So r is 11.4 centimetres, 11.4 centimetres. Now we're going to find t. So let's have a look at what side t corresponds with. So t corresponds with this side. So we're starting with the bigger, trying to get to the smaller. So we divide this time. 19.5 divided by 1.5. So t is 13 centimetres. Question 25. Vaughan cycles down a track from the top of a mountain to the bottom. The track goes down at an angle of 48 degrees to the horizontal. Vaughan is 800 feet above ground level. So then we've got a diagram. So this is the 48 degree angle to the horizontal. This is the 800 feet above ground level. And this is the top of the mountain to the bottom. And Vaughan's going to cycle down. Diagram's not drawn to scale, so we can't measure anything directly from it. Part A. Vaughan cycles from the top of the track to the bottom of the track. What distance has he cycled? So if he's going from the top to the bottom, he's travelling down this side. And if you look, guys, we have a right angle triangle formed here. So we're going to work with a right angle triangle. Okay, we know that this is 800 feet. We want to know the distance he's cycled, so let's call that x. What we're going to do is work out this angle here. Now we can work this angle out because to the horizontal is 90 degrees. So 90 take away 48 is 42 degrees. So that angle there is 42 degrees. So we've got a right angle triangle. We've got a side that we're trying to find and another angle that we know. So we're working with trigonometry here, guys. So trigonometry for right angled triangles. So let's label our sides. Opposite the right angle is always the hypotenuse. Opposite the other angle is always the opposite, which means this must be the adjacent. Now we are looking for the hypotenuse and we know what the adjacent is. So we're working with the adjacent and hypotenuse, which means we're working with the cosine ratio because equals A over H, okay? You may use formula triangles to remind you of this from SOHCAHTOA, guys, okay? So I'm going to substitute what I know in. So cos of the angle that I know, which is 42, is equal to the adjacent, which is 800, divided by the hypotenuse, which is our x. Now I'm looking for the hypotenuse. Now if you're somebody that uses a formula triangle, if you cover the hypotenuse up, it tells you to do the adjacent divided by cos. So x equals 800 divided by cos of 42. And I'm going to put that in my calculator. So that's 1076.506. Okay, so he's cycled 1076.5 feet. They don't tell us to round it to anything in particular, so that's how I'm going to leave it. Part B, state an assumption that you have made in answering part A. Well, the assumption I've made is that this is a straight line and there's not any bumps or veering off track or anything. So I've just assumed it's a completely straight line from top to bottom. So I'm going to put that it was a smooth straight line from top to bottom. So the next bit, if your assumption is not correct, what effect would this have on your answer to part A? Well, if this wasn't a smooth straight line, then if you had to veer off track, or if it was like a wiggly cycle route from the top to the bottom of the track, then he will have travelled a further distance than what I calculated. So he would have travelled further, so my answer would be bigger.